So by the principle of mathematical induction, that for all n greater than or equals to 2 and n belonging to the set of natural number, the following inequality is true. Okay, let us begin. So first what we'll do, we will consider a mathematical statement which is denoted by P of n. So let us say, let P of n be the statement. Let P of n be the statement such that we have the inequality 1 plus 1 over 4 added to 1 over 9 plus 1 over 16 going all the way up to 1 over n squared. We're saying that this sum is less than 2 minus 1 over n. So this is our mathematical statement. Let's label this as statement number 1. We need to verify that this statement is true for all n belonging to the set of natural number, and it must be greater than or equals to 2. So that means what we'll do, first let's verify if it is true for n equals to 2 or not. We'll not consider n equals to 1 because here it's clearly mentioned n is going to be valid only for values greater than or equals to 2. So we'll take P of 2. So P of the statement P of 2, this is now going to become, we'll have to take the first term which is 1, and to it we're going to add the second term, that's 1 over 4. So this must be less than 2 minus 1 over n, so n value that's 2. So 1 added to 1 over 4, so that's going to be 5 over 4. This is less than, so 2 minus 1 over 2, that's going to be 3 over 2. Now 4 and 2, the denominator of each of the two fractions that are positive, so we can cross multiply. So we have 5 times 2, that's going to give us 10. 4 times 3, that's going to be 12. And since 12 is greater than 10, so we can say 3 over 2 is greater than 5 over 4, which means that our statement is true. This simply tells us that P of 2 is true. So this is a true statement. But we'll have to verify that it is true for other natural numbers as well. So what we'll do, we will assume that let the statement P of m, let's say that the statement P of m be true. So this is going to be a true statement. So if this is a true statement, then we'll have to specify what is P of m here. So the P of m, that is simply given by, we have 1 plus 1 over 4 added to 1 over 9 going all the way up to 1 over n squared, but we'll use n and replace it with m, so it is m squared. This is going to be less than 2 minus 1 over m. So this is statement number 2. So we're supposing that this is a true statement, and with the help of this statement, our goal will be to verify. Our goal will be to verify that if we consider the next consecutive natural number, which is m plus 1, P of m plus 1, the statement must be true as well. That is our goal in this problem. Must be true as well. So what is the statement P of m plus 1? Let's try to write it down. The statement P of m plus 1, this is simply given by, we have 1 added to 1 over 4 added to 1 over 9 added to 1 over 16. This goes all the way up to 1 over m squared. But we'll also have to consider another term which is 1 over m plus 1 whole square. We'll have to show that this sum is less than 2 minus 1 over m plus 1. We're replacing m with m plus 1 in statement number 2. So this is what we need to verify if this is true or not. Okay, so let's do that. Now in order to verify number 3, statement number 3, we're going to take the help of statement number 2, because we have already considered statement number 2 to be a true statement. So from statement number 2, we have 1 plus 1 over 4 added to 1 over 9 plus 1 over 16 going all the way up to 1 over m squared. We have said that this sum is less than 2 minus 1 over m. Now what we'll do, we're going to add one extra term to both of the two sides. So we have 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 going all the way up to, we have 1 over m squared added to 1 over m plus 1 whole squared. So we're saying that this is less than 2 minus 1 over m added to 1 over m plus 1 whole squared. Fine. So there's an extra term which is 1 over m plus 1 whole square. We are adding to both sides. Fine. We'll keep the left hand side of the inequality as it is. Let's work with the right hand side. So here we have 2 minus. So if we take 1 over m plus 1 as the common factor, so we have m plus 1 over m minus 1 over m plus 1. Right. So that means we have 2 minus 1 over m plus 1. We can combine these two terms. So that's going to give us m squared plus m plus 1 divided by m squared plus m. Fine. Now here, we can straight away write from this particular step to the next step, which is less than 2 minus 1 over m plus 1. This is going to be a true statement. Now let's try to understand why this is the case. Okay, so here, let's try to understand this, why this is the case. So we know that m squared plus m plus 1, this is definitely going to be greater than m squared plus m, right? That's for a fact. If this is the case, this simply means that this expression m squared plus m plus 1 over m squared plus m, in other words, we can say that m squared plus m plus 1 divided by m squared plus m, that entire expression must be greater than 1. Right. If this is greater than 1, then we have 1 over m plus 1. This is multiplied to a factor which is greater than 1. And that ultimately means this entire expression 1 over m plus 1 multiplied to this expression m squared plus m plus 1 over m squared plus m. This is going to be a big number. And since we are subtracting for 2, whatever value we get, that value is always going to be lesser than 2 minus 1 over m plus 1. Okay, let's write it down. So here what we are getting is we are saying that 2 minus 1 over m plus 1 multiplied to m squared plus m plus 1 divided by m squared plus m. We're claiming here that this entire expression, this is less than 2 minus 1 over m plus 1. Okay, the logic being m squared plus m plus 1 over m squared plus 1, this factor is greater than 1, which make this a much larger number. So here we only have the factor 1 over m plus 1 multiplied to 1. So definitely, so subtracting 1 over m plus 1 from 2, this number is going to be greater than subtracting 1 over m plus 1 times a factor which is greater than 1 from 2. Okay, so that is why we were successfully able to write that 1 plus 1 over 4 plus 1 over 9 going all the way up to 1 over m squared plus 1 over m plus 1 whole squared. This entire sum is less than 2 minus 1 over m plus 1. So from this, we have been able to show, from this particular inequality, we have been able to show that the statement p of m plus 1, this is true. This is a true statement. And if it is a true statement, then what we have obtained here, that thus, if p of m is true, so we started out with this assumption that p of m is true, this implies that p of m plus 1 is true as well. So this is also true as well. So we can generalize this and we can finally say that hence our original statement p of n, this is going to be true. The original statement p of n is true for all n belonging to the set of natural numbers n. That means any natural number that we pick up, it's going to be true statement with the condition that n is greater than or equals to 2. Any n value, the natural number must be greater than or equals to 2. Hence proved.